Hi, here we have points E, F, G and H. They lie on the sides AB, BC, CD and DA respectively of a square ABCD. So let's draw a square ABCD. So this is original square A, B, C and D. Now E lies on AB. So let's say this is E. Or let's draw E somewhere here. Why is it so? I'll explain later. E is here, F is on BC, so F is somewhere here, G is on CD somewhere here, and H is on DA somewhere here. So now if you join E, F, G, H, if you join E, F, G, H, this figure that you get is also a square. Since this is also a square, EF will be equal to FG, which will be equal to GH, which will be equal to HE. And also we already knew that A, B, B, C, C, D and DA will all be equal because it is also a square. Okay. Now it is given that this square EFGH, the area of this square is 62.5% of the area of the bigger square ABCD, and also CG is longer than EB. Now since this is a symmetric figure, if CG is X and GD is Y, if we assume this to be X and this to be Y, then DH will also be X and this will be Y. Right? This is a symmetric figure. This will be X, this will be Y, and this is X, this is Y. A square is a symmetric figure, right? So all these will be equal. You can also prove them by proving that this triangle and this triangle, both these triangles are congruent triangles. They are both congruent triangles. Basically this angle theta will be equal to, if this is theta, this is going to be 90 minus theta and this is going to be theta. And if this is theta, this is going to be 90 minus theta. So this angle is equal to this angle is equal to this angle. So both these triangles are similar and the hypotenuse is same. Since it is a square, hypotenuse is same. So both these triangles will be congruent triangles, right? I'm not going to going deep into it, but you can simply also by observation say, since it's a symmetric figure, these triangles will be congruent triangles. So if this is X and this is Y, we will have X and Y in the same fashion all around, right? So what will be the length of this side? The length of this side, since this is a right angle triangle and this is the hypotenuse, HE is the hypotenuse, so this will be square root of X square plus Y square. Right? Hypotenuse square is sum of the squares of the other two sides. So we have this. So now we have area of triangle ABCD is, what is the side of ABCD? X plus Y. So area is side whole square. So this is the area of square ABCD, and area of square EFGH. What will it be? Side of this square is square root of X square plus Y square. So area will be square of the side. So square of X square root X square plus Y square. And we are given that area of this square is 62.5%. Now 62.5% effectively is 5/8. So area of this triangle or square is 5/8 the area of this square, which is X plus Y whole square, right? So let's simplify or solve this. Root of X square plus Y square whole square is X square plus Y square. This is equal to 5/8 of X plus Y whole square, which is X square plus Y square plus 2X into Y. Cross multiplying it here, we have 8X square plus 8Y square is equal to 5X square plus 5Y square plus 10 times of X into Y. Bringing all the terms on the left hand side, we have 8x square minus 5x square is 3x square. 8y square minus 5y square is plus 3y square. And 10xy comes and becomes minus 10x into y. This is equal to 0. Okay. Now dividing the whole equation with y square. So this becomes thrice of x upon y whole square. Dividing this by y square will have x upon y whole square minus 10 into xy upon y square. So 1y will get cancelled out and we will get x upon y plus 3 is equal to 0. Okay. Now considering x upon y as, let's say, t. Considering x upon y is equal to t. So this quadratic effectively becomes 3t square minus 10t plus 3 is equal to 0. Now using splitting the middle term method, we can write minus 10t is minus 9t minus t plus 3 is equal to 0. So taking 3t common here, we'll have t minus 3 remaining, and taking minus 1 common from here, we will have t minus 3 remaining from here, which will be equal to 0. Again taking t minus 3 common from both these terms, we'll have t minus 3 into 3t minus 1 is equal to 0. So we have t minus 3 into 3t minus 1 is 0. That means either t minus 3 is 0, hence t will be equal to 3, or 3t minus 1 is 0, so t will be equal to 1 by 3. Now we know CG is longer than EB, that means x is greater than y. If x is greater than y, that means x upon y should be greater than 1. Hence the value of t should be greater than 1. So we will not accept this value. We will only accept t greater than 1, wherein t is equal to 3. Fine. So the question was, what is the length of EB and CG? So we have to figure out y upon x. We got x upon y. We got t3, right? So x upon y is 3. So y upon x will be 1 upon 3. Option D here will be the right answer. Fine. And now coming back to the original point where I said I did not draw E here, but I drew E over here, because it was given that CG is greater than EB. So basically AE should be greater than EB. CG is same as AE. AE should be greater than EB. That's why I drew E over here. You could have drawn like this also. Calculation would still remain the same. You just have to make sure that at the end you accept only greater than 1 ratio of x upon y. Less than 1 ratio will be rejected because of this condition. Thank you.